Righty ho, we're live, and we're just going to give it 5 minutes so that everybody can climb in and get on board, and so we're just going to wait a 5-minute break. I suppose I've got to set up my screen size so that it's a bit bigger. Okay. Wrong screen. So just adjusting the code window so we've got some, so we can see something at least, right? Looks right. Maybe a bit too big. Looks alright to me. Right, another 2 minutes. I'm just running the wallet, getting that ready. Seems that I've got everything running on my one laptop. It's crunching the CPU. Hi, Roger Rabbit, you're back. Sorry, I'm just busy. And we've got Pedro. How's it, Pedro? Clear, we good? I don't know, last time you guys were saying that my speaker or my sound was a bit low. Can you just say, can you hear me? It's all good. Still low. Roger Rabbit says it's fine. So what I'll go through today is the wallet, how it features, how it works. I've stripped down quite a lot of code, and I'll go through the ring signatures and the south addresses and how actually that works and why it works. So you'll probably see that I have created the Genesis block, and I'm going to use that as a payment, and I'll send it over to the node, but I don't have any nodes running, so I can't actually show you APZ. I can't actually show you how it's all going to fit together, because I'd rather take it through to the tester side But what I can show you, I've made some modifications to the proof of stake, and it will be working as intended, so we can actually see how that part works. I have delivered the proof of stake economic rewarding distribution to Sweet Sneak, and he's been looking at it, so he'll get back to us as soon as he's given it to the once over. Okay, so I'm gonna start. So basically, I got the wallet up and running. It's here in the command line. Things have changed. They're not a prefix or starting with wallet address or wallet balance. It's just address, balance, creates, and so forth and so forth. So it's really pretty simple. So if, for instance, if I just want to see what my address is, if I just spell that right, I'm just flipping windows to get the wallet ID quickly. So I'm going to say wallet address, and it's going to ask me for an identifier, which is my wallet, and passphrase. So I know it looks like my screen is just slightly delayed, but it is getting there. I don't know if it's playing catch up with you, but I've got a separate screen watching the chat. So I don't know if it's the same for you, if it's for me, so I don't know, but if cool, thanks a lot. Right, so if we go to receive payments, I've already received the payment from the Genesis block. Let me just do that now. If I can just spell receive. So let me just see what is it going to do exactly when I get it. So with your receive payments, it will work the same way like it does with Monero, where you can provide, well, I actually want you to provide a payment ID, but if you don't want to provide a payment ID, then you're just going to have to scan the blockchain and look for a payment through those means. Okay, so it has a 15 to a 10-second delay. Okay, cool. I've never really done live streamings on Twitch or YouTube, so first time newbie. Hope it all goes well. I'm sure I'll get more experience, but anyway, so I'm showing the payments ID, and I have a payments ID from my previous transaction, which was the Genesis block. I haven't made any other payments because I've been testing the zero knowledge proof in the ring signatures when Alice pays Bob, and Alice tries to take away the output from Bob, which is the commitment. So I'll go through those steps now, but if I put in the payments ID and I hit enter, it will go and receive the payment. Right now it's obviously hitting the node. My computer is just slightly bit slow because it's running all the software. It's got OBS, it's got 2 versions of Visual Studio open, but it's doing what it's doing. So it's coming back as a Testnet 2 version 2.0 Genesis block pingpong sneak. It's got a date in there and received, and I've just put in there 64,400,000 or 64.4 million, and that's not something that's that's set in stone. Obviously, it's just some number that I've just picked up, and I'll just put it in there, right? So I've received the payments. I can also see history for that payment. switching windows. I just need to get the wallet's ID. So every time you want to make or interact with the wallets, you're going to have to put in your identifier and passphrase. We will probably, if you want to, we can have it as a floating session. Floating session, and then you'll be logged in until you log out or you idle, something like that. But I mean, that's nice to have. Obviously, it can come at a later stage. So was the payment on Testnet 2 or you just on your own network? Okay, so what I've done is to create the Genesis block on the node side is a bit of an intricate piece of work. So I have to go in and make a payment, pay myself. I then have to serialize the payment to hex. Obviously, that's just the way protobufs work in .NET. When you serialize and you deserialize back, I can create a hexadecimal string format, and then I can convert from hex to bytes and then back into protobuf. But what I have to do is just that. I have to create a payment. I'll actually show you how I did it. And then I have to go back onto the node side, and then I have to run the proof of stake. So there's a setting in the app.json app settings.json file on the node side, which has staking, I think, and on off. It's either true or false. True being yes, you're staking. False, you're not participating. So I turn that on, I run it, and then there's a background worker that kicks in and then runs that method every 10.1 seconds. Well, when it steps into that piece of code, then I'll have to deserialize the hex to bytes and then get the transaction, and then I have to make sure that all the validation and the cryptography works out in terms of the ring signatures, and there are a couple of rules that I have to step past, but I know that the Genesis block that I've created is correct. Once I've done that, then I save it to the delivered table or the delivered pod in the key value pair, and then I can then connect it to my wallets, and then I can hit it. So that is basically the transaction that I created, and then I'll go through the step just doing that. Okay, so what I'll do is I'll create a payment to someone else, and then I'm going to put on breakpoints. So what we'll do is find exactly where it's going to hop into. My laptop is a bit slow at the moment. I've only got 8 gigs of RAM on this thing, so it's eating my memory. Okay, so I put a breakpoint down, and we're going to do a spend payment. So it's just spend, hit enter. I have to get the wallet ID for that master, which is the Genesis block, and then I'll also show you that when we do start testing or we go live, that I haven't put any other value in here than the total supply, or what is going to be used as a total supply and float. So there's nothing up my sleeve, and we can validate that is the amount that I started the Genesis block off with. So that would be using the scan key for that transaction. So at the moment I'm just putting in the receiver address, which is obviously a different address that I'm going to be paying on, and I'm going to put in an amount, and I'm just going to go like, okay, well, I feel generous and I want to go large, right? And I'm just going to put in me for a reference as a memo, and I'm going to hit go, and we're going to start to step through the code. So okay, so the breakpoints hit, it will go through the session, get a session if you don't have one. It will then go and sort your change out. If you don't have any change, then it's going to tell you to go away, get some more money, or go beg on the streets, or whatever you want to do. So and then once we step in there, we'll go and create a transaction. Okay. I'm going to step right through to probably where the important bits are. The rest is you can go through on your own if you want to, or if you need to ask any questions, or ask questions. But what we'll do here, when it does the prepare for the ring signature, let me just see if I can get that all in the screen there. So I'll just put a breakpoint there, and then we're pretending we're going to set a payment through, and I'm going to run it, and I'm going to break it through. Okay, so what it does is to prepare the ring signature for creating cover. So you got n of or many of out of n signatures on the ring signature. Is that for the confidential transactions to work out on the ring signature, you got to tell the ring signature where in a specific index you are placing your output for, say, for Bob, right? And what will happen is when Alice pays Bob some money, she will uncover for Bob, so that Bob can have a one-time public key recorded on the blockchain for that transaction. However, she will do another one-time public key, so that Bob can actually see that transaction was for him. So when Bob comes along, he takes that ethereal one-time public key that he uses to do a Diffie-Hellman key exchange actually with himself, because he's got a scan key. He then gets and recovers the actual one-time spend key for spending his outputs, which means that Alice giving him the transaction and knowing the value and also the blind within that commitment, Alice can't go ahead and pay Bob and then pretend, or not pretend, but go at a later stage and take his transaction away. So the way it works is once we put the mechanisms in place that Alice uncovers for Bob, but what she does is she can't uncover his private key. She can only do his public key, because she has this ethereal one-time key to give to Bob, so that Bob can do like a Diffie-Hellman key exchange with himself, and then for that purpose only he can recover his own private key and public key. But Alice and Bob will definitely share a public key together, right? She can obviously see the payment because she's made the payment. She knows what the value is, and she knows what the blind is, and she knows what the actual one-time public key for that transaction. But the nice thing is that Alice will never know when Bob actually goes and spends that transaction, and this is the reason why you've got the ring signature. So Bob will go ahead and he'll use that ethereal one-time key that he received from Alice. He will also then have recorded on the transaction in the blockchain that this is the public key that I'll be using as my one-time public key that I'm spending with, because I've got the private key. So what he'll do is he'll go and download some cover beforehand, and he'll use the commitments that are stored on the blockchain with the public addresses, and when someone from the outside, or even Alice for that matter, goes like, did Bob go and spend my payment? Well, she doesn't know. because what Bob does is he goes and spends his transaction, but he goes and spends it in such a way that he puts it into the ring signature, and he then creates a lot of cover for his outputs and adds a lot of public keys for the one who actually signed the ring signature. And that's basically how ring signatures work. Now, on the node side, all we do is we have to check to see that, okay, you've included that commitment within that transaction, plus there is a public key that is on the transaction. So we don't know which public key was used, and we don't know which output was spent, but because those two elements are there, that means that one of those public keys are the ones that signed the ring signature, therefore it must be valid, right? But we don't know which one it is, as long as we can refer back to commitments that you've actually put it in there as the Patterson commitment, which is your value, and then there is a public key that ties in with that actual transaction, but we don't know which one signed the transaction. All we know is one of those public keys signed the transaction, and one of those outputs are being spent. So that's in a nutshell how it works. I won't go into further detail exactly how it actually gets set up and gets used and stuff like it. It's just basically out of scope of this stream, right? So I'm just busy stepping over the code. So what happens is he goes and locks his wallet. He needs to get his spend key and his scan key. He then deserializes the scan, the message that Alice tucked away for Bob inside that the wallet message. Inside there we have the blinder value and the memo field that Alice is sending to Bob. I don't know if you can see that, so that's my immediate window. Hopefully it pops up if there's a 10-second delay. But inside this packet that Alice sends Bob, she gives the amount, she gives the blind for the commitment, and she gives a memo. So yes, I paid you X and Y, and this is the date I paid you on, whatever you want to put in there. That will be at least 64 bytes big. Right. Sorry, I'm just reading the screen here. Someone mentioning Horizon. I don't see my immediate window popping up, so okay, so we'll just carry on. Anyway, so that would be the little packet that Alice packages for Bob, so that he can get the blind and the amount, so that he can recreate the commitment on his side. And then she obviously gives him a memo. It's not mandatory, you know what I mean? It can be empty. And then if we step over down to the one-time spend key, basically that is the private key we're going to use to sign the ring signature with, and that is the one-time spend key that Alice can't get to, but she can get to the public key for that that one-time public key. So at that point we have already worked out how much our balance is, and if we're going to send or the blind that we're uncovering for that output, so that it actually equals what's on the blockchain, so that when we do a lookup, we can actually see, yes, that output actually existed before we actually spent it. Therefore, it was true, and no one's trying to create money out of thin air, right? So, okay, so we just step over that. We're going to do a blind switch. We'll get to that later. And the white paper will also explain these things that I'm just stepping over. What's a blind switch? Or, go through Patterson commitments, go through the ring signatures. So my next line would be where the one-time spend key on line 697, right? That would be the public key for that one-time spend, and he's going to add it to the ring signature. And then right at the bottom here, I'll just make it a highlight where it says make fake inputs. Those make fake inputs will be replaced by actually what I call safeguarding the transaction. So what will happen is your wallet will on first go it will download maybe a day and a half's worth of block headers, and it will then use those block headers, block header transactions, to go and sort through and create cover for your outputs. So because we're not sitting on a full node and we don't have the full blockchain on our local side, if you're just running a wallet, if we didn't do that and we just asked the nodes, give me 17 or 22 transactions because I'm ready to make a transaction, then you're basically telling everybody what transactions you're downloading from the node and actually what is your output you're spending, right? So we don't want that. So we're going to create cover for the wallet. So when we create, or we want to create cover for the transaction, so we want to download 1.5 days worth of data, or maybe even 20 megs or whatever it takes. But we will use those transactions to create the mix. And then that way no one really knows exactly where you're putting what. Yes, sure, you've got 20 megs to play around with, and we can do some analytics on it, and we can try and deduce exactly where you're going and do what exactly. I mean, okay, go and have fun, right? So that's how we're going to create cover. So that will be replaced by safeguarding the transaction. So now my computer's frozen because it's struggling at the moment. I'm trying to get out of the window. I'm just going to step through the code, put another breakpoint down, and just run through it until it hits. Okay, so basically I've just gone steps ahead because I've already got my one-time key. I've signed the ring signature, and now I've gone and created my transaction. At the moment you'll see I have a t equals this, which is a code that I haven't taken away because I've created my Genesis block out of it. But that obviously won't be there. But the way I did it is I did exactly this. I broke or stepped onto the specific line, and I said to the thing, give me the hash, the hexadecimal string from this bytes array, and I'm going to use that to go and create my my Genesis block out of it. And that's basically what I did. So we're gonna now just step through it, because here from here on in we're actually gonna create the transaction, and then we're gonna send it to the node. Obviously there's a couple of things that I'm missing here because I haven't put in the offsets in here, so it won't work. But what we'll do is we'll just go straight over to the node side. So when I'm finished with this part, it should be by tomorrow sometime, I will have the testers available, because they're asking, we need to start with the wallet. So I will put this down, for them to start testing. Again, it's got to be a focused test sequence. We're going to do this and we're going to do that before we let it out to the public. But in a very short time, we will all have the opportunity to run either A, the wallet, or B, the node, and then or both, right? So that we can all participate and all go crazy and all send coins, and we can all break it and go like, oh, I found this, I found X, and whatever, right? So it's going to be fun and games. But for now, we want to get everything ironed out as much as possible, so that we can actually use it, and there will be less questions and how do I do this, how do I do that. So the wiki will be there, the documentation will be, the guys that are busy doing it right now, like, they're doing a great job. They're going through it systematically. They're creating clusters, they're setting the clusters up. Inca has gone and written us install scripts for Linux, same with Mac, Linux, Mac, same flavor, and for Windows. So we're trying to make the install process as smooth as possible. Sure, there are a couple of things to work out, but as far as what I've seen, is it's great. It's just almost like a one-click install. Yes, you got to have some SDKs available for .NET to run, but I mean that's a given on any language you choose to run with as a virtual machine or a framework. So let me carry on here and see where it's going to go. So at this point, we're going to create the transaction. We're going to create the structure for the transaction. My transaction size isn't that big. It's about 1.1 kilobytes currently, but that's because I don't have any offsets, and those offsets are obviously the reference points to the commitments and the public keys, so that we can tell the node that this is what we used when we put them into the ring signature, and this is what you need to go and find to actually make it verifiable, so that I didn't create money out of thin air. And obviously that key image was added, and it wasn't presented anywhere other than what we're giving it now, and it's not anywhere on the blockchain, so there's only one of them. So I'm just going to step through here and go in here, and okay, so that's going to do stream. It's going to check to see if there's an overflow. We don't. This is just a little check that I've put in so that you can't go over the determined buffer size for that or for a transaction. This is not set in stone. It's just something that I've put in there for testing. So just stepping out of that. So we succeeded, and so all the checks work out and all the commitments are working out, and the bulletproof is working out, so is the ring signature, and we're now going to go and check to see if we've already got this added in there. If not, then obviously there's the transaction exists, so don't save it, and if the wallet transaction exists, then obviously don't save it. If it doesn't exist, then save it, and then we need to obviously send it up to the node side. So what I want to do is quickly is take that transaction, and I want to just quickly serialize it. Oh, maybe no, wait. Okay, don't worry. I can use the previous one. We'll make it easier. So what it will do is it's going to go and do save everything into the wallet so that we can retrieve it later, or see what our balance was, and it will record another transaction on the wallet side, so that when I do a history, I can go and check to see what I've sent. Was it a money out or money in, and then what was the balance for that that transaction. Right, so let me just step through the code here. It's going to moan because whatever. My computer is really slow at the moment. The OBS stuff really kills my PC. I mean my laptop. So I'm just trying to wait for it to go on to the next line. This is like watching paint dry. Okay, so it's going to insert the transaction because it hasn't found another session with that same session ID. Inside the wallet transaction will be limited information like the date it was sent, the transaction ID, and the address. It doesn't store it doesn't store as much information as you want to have it stored on a normal database, because everything is already there. The transaction I get directly from the node, I store that on the wallet side. So when I want to use the transaction for the output, I don't have to have the values available or the memo available. I don't want to store that in case your wallet gets compromised. It's already got a layer of encryption on there, so when you open the wallet, you have to have your wallet ID and your passphrase to actually open the wallet. But let's just say they got through that, they won't actually get anything other than JSON structure. So hopefully, well, not hopefully, that the what I don't store on the wallet transaction is values in the clear. What I normally do is I just decode it first or decrypt it, and then use it, and then store whatever I need. So I'm trying to store as little of information as possible. So I just think that's better housekeeping than just having everything in a locked wallet and be dependent on the security that's on the outside. I think we should also worry about the security on the inside. So continuing with creating the transaction, saving the wallet transaction. It's now going to actually save it straight onto the wallet itself. My laptop's just taking a bit of time because of this. It's like when you've gone to go pay your telephone bill or something like that, and you're standing at the counter, and the lady says, "Can I have your account number, please?" And she puts it in, and she's like, "Sorry, the computers are slow today." Well, that's my excuse. So just going through, trying to save the transaction. Whenever it's going to get there, it feels like forever. Right. Okay, and we're almost there. Anything anybody wants to ask while I'm trying to step through the code, or does everything make sense? It's obviously crashing there for some reason. Okay, so my session already exists for that one. So we got I already tested this earlier. So that's basically on the wallet side. So I can show you exactly what I changed on the node for the proof of stake, and then we can wrap this up, and then I'll get back to work, and then I'm gonna try and have this out by the latest on Tuesday or sometime, so that the testers can actually start making transactions and carry on with the testing. But there's no more real implementation to implement in terms of breaking your head open over cryptography and how does the net zero knowledge work proof works, or trying to do this very hard technical thing, because it's already been done. All it is now is just going through all the code and making sure that we've hit all the notes. We've hit all the notes, and we've done everything correctly. So we can pop over to the node side, and then I can show you how the proof of stake has changed slightly. I've added a couple of things in there to make it slightly different, because at the moment it's too fast, so I needed a way of slowing it down, and then I can actually show you what the output will be for that. Maybe I should just run the test bed, and you can see exactly how it works. So I'm just going to stop that, because this is eating my memory. I'm eating everything basically. I think I need to get more memory. So in terms of code-wise on the node side, nothing has really changed. Only a couple of things here and there. I was swapping screens over. The REST wallet API is still available, although features from the CLI. Right. So the REST API for the wallet has changed. I've taken basically everything that's there and I've dumped it. Okay. The only REST that is available is the proof of stake. The proof of stake when you do the staking from the node side. So I'll show you that piece of code. So that's basically it. That's the only REST that's there. You'll have to obviously either copy code from the previous one and add it in there. I just thought, when I implemented the ring signatures, I ripped out as much as I want out of the code, because I felt it was unnecessary and I needed to start with some sort of a clean slate, and that's basically what I did. So right now the wallet and the node is bare minimum to make it work, so that we've got fees, fast feeless and privacy. We can obviously implement anything on top of that once we've got it all working and things have been ironed out and all the kinks worked out and stuff like that. But you can definitely take the previous wallet and apply that logic to those REST APIs. But I mean, at the moment there's only one in there, and that's called bandpos. So that will basically look at the coin stake transaction that you're trying to create from the algorithm. You then pass it down the wire to this endpoint over here, and then your wallet will then go and create a transaction for you. And if it doesn't have the money or the means or the funds, or it crashed, or it had a bad day or whatever, it will return a null value, it will return a null value, meaning that you either don't have money or something happened on the wallet, so you miss your turn, right? There's no point in you trying to pause your node and see what happened, or whatever the case is. It's not going to work like that. Once you've missed your go, there's going to be someone out there that's going to be faster than you. Whether you thought, well, this is a good reward and you're going to get a nice payout, doesn't matter. Your turn will come just like everybody else's. So that's the only rest point that's available. We will obviously put in more for interacting with the wallets from an endpoint perspective, but at the moment there's only one. So I'm just going to swap over to the node side. There's so many fucking screens. Okay, that should flip over. Right, so hopefully I chose the right window, and so there's not really much that changed. What did change is the way the solution gets worked out. Like I said, I needed to slow it down. The solution was calculating too fast, thereby giving you no reward. And the verify delayed function would have just gone through instantly. So the only thing that would have kept you from not broadcasting any transaction is the time gap or the slot between block headers. As you can see over here, there's still remnants of what I did earlier, creating the Genesis block. Obviously the previous Merkle root as whatever that is, at 00000. So if we just get to the solution for what we're basically getting to, and it's probably going to switch over now. So what I've added, what I've changed, and I will do a commitment later. However, I'll probably do a private commit with the wallet. I know Inca wants to start building a GUI, so that's basically what I'm going to do. So I'm busy building the safeguarding to download the block headers, so that when you create a transaction and you're spending the coin, you're going to have those outputs and those one-time public keys to create cover for your transaction. So then I will commit the wallet to the repo. For now, I'll put it to private, so that Inca can just have a look at it, and then I'll make it public, and then we'll go through the steps, what we need to have checked, what we need to have tested in terms of wallet. We'll probably have the same install scripts for the wallet. However, it's obviously not doing any clustering, but it will connect to a node, and at that point I would have to have the Genesis block ready for you guys to hook into, and then it should download it to your nodes, and then we can then go through the wallet stuff. So the changes on the validation for or the creating of the solution over on the POS side, on the node side, has changed to those two pieces of line, two pieces of code over there. So all it's doing is just taking the target's int value and is dividing it by the hash's target bit count, and it's creating a new hash target. So instead of using a 32-bit hash number, I've increased the size slightly bigger, so that when it does the calculation to do the multiplication and does the compare, that it doesn't just fall through after the second iteration. So now it's going to take like a couple of seconds, but those iterations are going to be like 1.2 million iterations, which is fairly quickly. And then obviously from that I use a calculation to determine how many iterations you need to spend on the verified delayed function. So I've updated that, and I'll probably push all of that stuff over. I think I'll do it tonight sometime, but here's a couple of changes that I've already made so far. Right, so we're good. I don't know how good it is. My internet's not that great, right? I've moved into even more of a... here we go. Okay, so we're back again. As I was saying, my internet's not great. I've moved even more to more of a remote location than my previous location. So I'm using 4G, and the room I'm sitting in isn't actually my room. It's my wife's. My wife's painstakingly changed my son's rooms into my my live streaming studio, so I'll be coming here and doing that. So I tried to get up this weekend earlier, but I just didn't have any luck with the internet. However, that will probably change once I get settled and everything's back to normal. If I can make it better, then I will. Right. So as I was saying about the node before I got cut off, so I've basically slowed it down so that you can have a decent amount of iterations within that multiplication sum, where it does the comparing between the hash target and the target, which is your verified random function, and the hash itself from the transaction. Now, the reason why I say it's random and no node will actually get to the same answer is because of a private key that you use to actually create or sign your proof for the verified random function, and then you do the calculation on it, which then produces this the signature that you use, which is supposedly to be random. So no node will actually come to the same number as you. So every node has a fair chance of getting the reward from what the algorithm is asking you. If you've got the money to cover it, then you've got the money to cover it. I'm not saying money, I'm saying coins. If you've got the coins to cover it, then great. If you don't, well, don't worry. You'll get a next round, or a next turn. Your turn will come, right? And the guy who has got a bigger wallet or a bigger spend amount, it really doesn't really matter for him, because if he does have the money to cover it, and I don't have the money to cover it, and we've landed on the same block with the same transactions, and we run it through our staking algorithms, we will get to a different solution, i.e. meaning, okay, so he got a bigger reward, but then he means he has to do more work through the verified delayed function, whereas I got a smaller reward, but my work on the verified delayed function is smaller, so my time to work out the sequencing from the algorithm is less. So if we were in a race and it was just him and I would win, right? So that's basically how it works. And hopefully what I've done here is fair. Obviously, the more eyes we have on it, the more people will get invested, the more people that are showing interest in Tangram and how it works and what is this proof of stake, that's getting used. They probably will come out and go like, well, there's faults here. Well, okay, cool. Can we fix them? You know what I mean? Let's do it that way, right? Time to buy. Yeah. In due time, right? I have written a small app that actually does exactly what it does on the proof of stake. I don't think I can. Well, I can show you, but I don't think I can show you in the immediate window because I have to actually snap this OBS software onto a window capture. So I could probably print it out to the screen. So there are a couple of fixes that I'm doing on the node side, but more work has actually been spent currently on the wallet side, just so that everything runs smooth, and then when I create the transactions that they are getting saved, that when there is a problem that you can roll back and you're not going to lose money, or you didn't send it out to the ether, now it's gone forever, stuff like that. So once I get everything up and running and it's smooth, like I said, I will put the wallet for now into a private repo so that Inka can have a once over, and maybe you can start planning out the UI like he said he wanted to. But I'm not going to leave it there for very long, so I'm going to then swap it over to public so that the testers can get their hands on it and install it and run it and connect it to their nodes. And then I will have the node that's got the Genesis block up and running so that it actually propagates down to their nodes, so that we can then kickstart this thing. It's just been a bit of a fiddle getting the Genesis block together and me creating these transactions from the initial start. I suppose this is all about what the blockchain is and why it's difficult, and we will have a procedure that will make it easier if people just want to take the code. We'll make a SDK out of it that is just a simple, seamless thing to do. You can just start your own network, your own blockchain, your own Genesis block, and away you go. I don't know if there's anything more, is there anything more I can, or you want me to show you anything more I can explain to you what's next. As far as I know, I think Sweet Sneak will put up a Medium post. I'm not sure, but what will be explained through that is what the test is busy doing, what they found. Have there been any roadblocks, and the progression in the testing side, I think will be made available to the community, just so that you guys are aware that there is stuff happening in the background, and that we are busy working. It's not long now. It's really around the corner. We're just setting things up so that we can get everything out and everybody on board. We're just working our way just to make it easier for you guys, so that there is no big headaches and roadblocks and go like, fuck, why didn't I see this, or what? No. We want to sort these things out. So by the time you get your hands on it and you actually run either the wallet or B, a node, or both, that everything's been worked out and we don't have a problem. And then obviously Sweet Sneak's work's cut out for him, because he's got to run the numbers, he's got to speak to certain people and get certain interests from everybody, and then I go on holiday. Just kidding. Then it's looking at smart contracts and integrating with Neo and stuff like that. So there's definitely not any rest for the wicked. So if you guys want to ask me any questions, I need to go through anything for you, then go ahead. Let's do it. My internet. Yeah. My internet's down again. Yeah, fuck, when 5G. So no exchange. Oh, fuck, I'm spelling it wrong. Can't see. Yes, hold, definitely. Oh, and then there's the question about the fee that I probably want to go through. Yeah, my internet shit. It's definitely shit. Okay, so when we have a simple way to set up the node in the wallet, well, that's been worked on currently. Inca has worked on scripts. That is either SH script or a PowerShell script, and you just run it once. It will then if you've got all the software that's required to run a wallet or a node, it will automatically store it into your environmental variable or your profile, so that you can just whip up the command line and run it directly from there. We will have a documentation or a wiki or a how-to to actually do just that. Later on, nice to have, we will have the script, you run it, and it will go and fetch the entire sync for it to run. And then you don't have to worry about anything other than just running the script. To update the wallets or the node, it's the exact same thing. It will go and fetch the latest version from GitHub, and then do exactly that from the beginning, while just installing the wallet or the node. So for now, yes, there are scripts, and it will be easier for the guys that want to put it into Docker. I know we have a guy that is an expert, and hopefully he'll help us out again. And we can just put the node into Docker for you guys who just want to do a one-click install. Then you don't have to rely on the script. So yeah. I think I need some coffee. My fucking mouth is dry. So if you want to ask Sweet Sneak any questions, I think he's on Telegram. We are definitely speaking behind closed doors. But if you want to ask him any questions, I think he's floating around on Telegram. The white paper, when we will have the white paper ready, Sweet Sneak is looking for technical writers in terms of people who can understand the workings of cryptography and the technical aspects around that, so that we've actually got a white paper. Well, I don't know, that you got to ask him yourself, right? You can ask me the same question, why am I on Discord and not on Telegram, right? I think maybe it's a different personality.